Have you ever really stopped to think about what's happening when you send a message or stream a movie or jump on a video call? It just works, right? It feels instantaneous, totally effortless, but underneath all that, there's this incredible, sprawling structure of hardware and software making it all happen. So today, we're going to pull back the curtain. We are going to build the blueprint for how it all works. First up, let's look at the game plan. Okay, here's our journey. We're going to start with the big picture. I'm talking networks by size, from the phone in your hand all the way up to the entire globe. Then we'll follow the internet's path right to your front door. After that, we'll peek inside what I like to call your network's command center. And then we'll get our hands dirty with the actual physical cables and tools. And to wrap it all up, we'll blast off into the amazing virtual and cloud worlds that all this hardware makes possible. Sound good? Let's go. All right, first things first, let's get a sense of scale. It turns out the most basic way to think about a network is just by how much physical space it covers. So we're going to start super small with a network that basically follows you around all day, and then we're going to zoom out level by level until we're looking at the whole planet. So, quick question for you. How are you connected right now? Seriously, think about it. Is your phone talking to your smartwatch? Is your laptop connected to your wireless earbuds? Chances are you're using multiple types of networks at this very second, and you might not even realize it. So let's put some names to these things. Okay, the smallest one on the list is the PAN, which stands for Personal Area Network. And honestly, the best way to think about it is like a little bubble of connectivity that moves around with you. When your Bluetooth headphones sync up with your phone, or when your fitness tracker sends your step count to an app. Yep, that's a PAN. All right, let's zoom out one step. Now we're at the LAN, the Local Area Network. This is the one you're probably most familiar with. It's your Wi-Fi at home, right? Or the network that connects all the computers, printers, and everything else in your office building. That's your LAN. Okay, time to scale up again. Now we're talking about a MAN, a Metropolitan Area Network. And this is basically what you get when you start connecting a bunch of LANs together across a much bigger area. Think about a big university campus with buildings all over the place, or even an entire city's public Wi-Fi system. That's a MAN. And finally, the big one, the WAN, or Wide Area Network. This is the top level. It covers a huge geographical area, basically by linking together all those LANs and MANs and other networks we just talked about. And here's the key takeaway. The internet itself, it's the ultimate WAN. It's just a massive global network of networks. Okay, so we've got this massive global WAN called the internet. But how does a piece of that actually get into our homes and offices, right? Well, that connection is made through what's called an Internet Service Provider, or ISP, and it turns out there are a few different ways they can get that connection to you. So let's break down the most common ways. A lot of us get our internet through the exact same coaxial cables that bring in our TV signal. Then there's DSL, which is pretty clever. It uses the existing copper phone lines in a house. The Speed King is usually fiber optic, which is amazing. It uses pulses of light traveling through glass strands. And of course, for when you're on the go or in a remote area, you've got satellite and cellular networks. The big thing to notice is that each one uses a totally different physical way to get you online. And this little box right here is a really critical piece of the puzzle. This is your gateway device. In this case, it's a DSL modem. And its whole job is basically to be a translator. It takes the signal coming in from the ISP's phone line and converts it into a digital language that your computer and your router can actually understand. And look, no matter what kind of connection you have, cable, fiber, whatever, you're going to have a similar device doing this exact same crucial job at the entry point of your network. All right, so the internet signal is now officially inside your building. What happens next? Well, a whole new set of hardware takes over. The best way to think about these devices is like the air traffic controllers for your local network. They're the ones managing where all the data goes once it's inside. And a key player here is something called a switch. Now, they basically come in two flavors. You've got your unmanaged switch, which is super simple. It's plug and play. You just use it to get more wired ports. That's it. But then you have the managed switch, and this thing is way smarter. It gives you a ton of control to configure settings, monitor who's doing what on your network, and it unlocks some really, really powerful features. And this right here is a perfect example of what I'm talking about. One of the coolest things a managed switch can do is create something called a virtual LAN or a VLAN. What does that mean? It means you can use software to take one single physical network and basically chop it up into multiple totally separate networks. So like you see here, you could have one VLAN for your employees and a completely separate one for guests. Their traffic never, ever mixes. It's an absolutely huge tool for security and for keeping things organized. But of course, let's be real. Most of our devices don't use wires anymore, do they? And that's where the wireless access point, or WAP, comes in. This is the gadget that actually creates your Wi-Fi signal. It acts like a bridge, letting all your wireless devices, like your phone and your tablet, connect back to that main wired network. Okay, time to get our hands dirty. You know, for all the talk about the cloud and going wireless, our entire digital world is still built on a very real, very physical foundation. We're talking about actual cables, connectors, and the special tools you need to put it all together. So on the left here, you've got the most common network cable in the world, twisted pair Ethernet. You definitely recognize that little plastic clip, the RJ45 connector, from the back of your computer or your PlayStation. And on the right, that's a coaxial cable, the same kind your cable company uses with those screw-on metal connectors. They both do the same job, moving data over copper. They just do it in slightly different ways. And if you're going to work with these cables, well, you need a specialized toolkit. Technicians have all sorts of gadgets. Cable testers to make sure everything's working, strippers and crimpers to build custom-length cables, punch-down tools for connecting wires into wall jacks. They even have Wi-Fi analyzers to see what's literally happening in the air around them. Check this out. Here's one of those tools in action. This is a cable tester, and let me tell you, it's an absolute lifesaver when you're troubleshooting a problem. You plug one part in at one end of the cable, and you take the other little receiver to the far end, and it can instantly tell you if the cable is good, if all the tiny wires inside are in the right order. It can even help you figure out which of the 50 ports in a server closet connects to the one jack in your office. Super useful. And hey, have you ever wondered how the individual wires actually get inside that Ethernet jack on your wall? Well, that's what this tool is for. It's called a punch-down tool. A technician uses it to take one of the tiny wires from the main cable and neatly and securely force it down into a little metal slot inside the jack. That's what creates the solid connection we all plug into every day. Okay, we've built our physical foundation, we've got the connections coming in, we've got the hardware to direct traffic, we have the cables and the tools. Now, let's talk about the incredible, kind of abstract world that this foundation unlocks. It's time to move from physical machines to virtual ones. And the key concept we need to understand here is something called virtualization. Now, it can be a little bit of a mind bender at first, but the core idea is actually pretty simple. It's the process of making one single, powerful, physical computer pretend to be many separate individual computers, all running at the exact same time. And this is what that actually looks like in practice. There's special software called a hypervisor. This one here is called VirtualBox that lets you create and run these virtual machines, or VMs. And if you look closely, you can see that this one physical computer is running Windows 10, Windows 8, and a version of Linux all at the same time. Each one is in its own isolated little window, and each one thinks it has its own storage, its own memory, its own everything. Now, here's the magic. When you take all that power of virtualization and you make it available to anyone, anywhere over the internet, well, that's cloud computing. And it's usually broken down into three main levels. At the very bottom, you have infrastructure as a service, or IaaS. Think of that as just renting the raw hardware, servers, storage, etc. A step up from that is platform as a service, or PaaS, where you're renting the hardware and the operating system. And at the very top, you have software as a service, SaaS. And this is what most of us use every single day. It's when you use a finished app like Gmail or Dropbox, and you don't have to think about the hardware or the operating system at all. You're just renting the software. So, there you have it. From the tiny personal network buzzing around you right now, all the way through the cables hidden in your walls, connecting to hardware that directs traffic, and finally reaching out to these massive virtual machines running in a data center maybe thousands of miles away, you now have the blueprint. So my question to you is, the next time you hit send or tap play, what part of that incredible invisible journey will you see in a completely new light?